after talking about tangent lines, it only makes sense to talk about normal lines. So a normal line to a curve is a line that's perpendicular to the tangent line at that point of contact. And therefore, since we know perpendicular lines have opposite reciprocal slopes, the gradient of the normal line to the curve, let's say y equal f of x at x equal a, is going to be the opposite of 1 over f prime of a. So let's look at a specific example. Find the equation of the normal to y equal e to the x minus 2 power at the point x equals 3. All right, so the first thing we need to know is if we're getting the equation of a line, we need a point and the slope. So the point is going to be 3 comma, and if I plug 3 in to my function here, I'm going to get y equals e to the first power, or just y equals e. So there's my point. And now I need to get the slope. So for the slope, I need to calculate the derivative. So y prime equals the derivative of e to a function of x is e to the function of x, and then times for the chain rule, but the derivative of x minus 2 is just 1. So there's my general derivative. And so now let's evaluate that derivative at e to get the slope of the tangent line. Evaluating that at 3 to get the slope of the tangent line, and that's going to be e to the first power, or just e. So that's the slope of the tangent. So therefore, the slope of the normal is going to be the opposite reciprocal of that. So it's going to be negative 1 over e. So I've got my point and I've got my slope. So I'm ready to write my equation. So let's do it in a different color. So I've got y minus e equals negative 1 over e times the quantity x minus 3. And you could go ahead and graph that, and you can, and your calculator, graph the normal line. As long as your window is in a square setting, you'll see that that normal line is perpendicular to your tangent line. Okay, just a handful of problems from this section, 18b, page 483.